going to just think about a few points here. So if I ask you for the sign of 0, what would you tell me? 0. Yes, the sign of 0 is 0, right? So on your graph, you're going to have a point at 0, 0. Okay, we could do these values in here at pi over 6, pi over 4, pi over 3. They're pretty ugly to plot on your graph though, so we're not going to do those. We're going to jump up here to pi over 2. Lower ordered pair there. So the sign of pi over 2, what does that equal? Yeah, 1. So what that means is on your graph, your first tick mark here, I'm going to label it as pi over 2. I'm going to put some labels on my y-axis there too. And I'm going to put a dot. We got 2 dots. Are we okay so far, guys? You're still with me? Okay. So our next one. Where do you think I'm going to go next on my circle? Yeah, I'm going to go over here. I ordered pair there, negative 1, 0. So what is the sign of pi? 0. Right? So what that means for my graph is that my next tick mark is going to be pi. And I'm going to have a dot back at 0. Are you following along what we're doing here? All right, so back to my circle. Where am I going next? Pi over 2. Good. So the sign of 3 pi over 2. What do you think? So what that means for me on my graph is my next tick mark is 3 pi over 2. And I have a dot down at negative 1. What do you think the last tick mark on my graph is going to be? And what is the sign of 2 pi? 0. Okay, so I have 5 dots. We could figure out the left side of our graph, which the labels are going to be the same thing, just negative. So I'd have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. That's fine. You could take the time and plug all of those values in and evaluate sine everywhere. Or you can follow the pattern. This is a sinusoidal wave, which means it's a wave that just happens over and over again. So let's look at the pattern here. This is kind of the middle of our graph. Low, middle, high, middle, low, middle, high, middle. Okay, you can just plot the points by following the pattern. That's completely fine. Okay. When you connect them, you do not connect them with a straight line. Okay, this is not an angular graph, it's a curve. If you think about it, you're coming from a circle to get all of these, so it's like the arcs of a circle, just to help you remember. Hopefully, you can draw better on your paper than I can draw up here. And that's what the parent graph for sine looks like. We've got those two things at the top, PER and AMP, that stands for period and amplitude. I'm going to do the amplitude first. I'm going to draw on here what's called my midline. I'm going to make it a dashed line. It's not an asymptote or anything, just this is the midline of your graph. The name hopefully makes sense. It's right in the middle, so it's your midline. To find the amplitude, you're just finding the distance from that midline to the top of your graph. So, like, that's as high as it goes. This distance right here, that's your amplitude. So what do you think it is for the parent graph here? Just 1, the amplitude of 1. Amp. Or midline, which okay, we still need the period. The period of a graph is just how long it takes before the graph starts repeating itself. So you guys see, I start at 0. After 2 pi, isn't it just going to start over? Okay. So this distance is a length of 2 pi. That's what the period is for the parent graph. Okay, questions on sine? All right, you're going to try to graph cosine. Do it exactly how we did sine. The points are obviously going to be different, but from your circle, figure out where you're going. Okay, so take a minute here, try to graph cosine. Start off by thinking about what is the cosine of 0. Okay. Guys, talk to each other, see how you're doing. Nope, amplitude's always positive. So it's just a distance.
Are these always going to be like the same? Not
For the
points.
parent graph, yes.
It's always going to be negative 2 pi, negative 2 pi, always going to be negative 5 over 2. So these are always going to be the same.
For the parent graphs.
For the parent graphs.
For those two parent graphs, yes. We're going to get into what we do with the area changes for the labels, but yes. That's
Okay.
what you should always start with. Okay.
Alright.
Yeah, so you're going to fall asleep in there? Did you graph cosine yet?
But
My patience is short today, guys. Alright guys, it looks like a lot of you got there, which is good. So your x-axis labels are the same. Pi over 2, pi, 3 pi over 2, and 2 pi. Do the negatives. make sure you give me some sort of label on your y-axis too, so I know if you're going by ones or twos or whatever. Cosine starts at 1, 0, 1, and you can follow your pattern over here. Okay, what do you guys think for the amplitude on this one? Still 1, and the period? Still 2 pi, okay? These are your two parent graphs for sine and cosine. Everything else we're going to do with the graphing of these is from the parent graphs. You're not going to plug in values, you're just going to take the parent graph and shift it or stretch it or change the period, something like that. Okay? So you absolutely have to know those two graphs. Okay. You know where they come from now. So this next little part, this is really a review from Algebra 2. So we need to look at this and figure out what is happening. So true for sine or cosine, you've got an A, a B, a C, and a D, which means there are 4 things that can change on the graph. All right, the amplitude, that piece that's the height, the distance there from the midline to the top, that is always the absolute value of A. You can even think of it as your vertical stretch. Okay, so the period, how long it takes for the graph to start repeating. You always start with the parent graph period of 2 pi, and then you divide it by whatever your b value is. So 2 pi over b. Okay, and b, do you guys see it's that coefficient right there on the x? So the parentheses with the x. And it's important that the b is factored out of the parentheses. You always need to have that b value outside of the parentheses if there's a shift. Okay. All right, so the c, that's inside the parentheses with an x, so that makes it a horizontal shift. If c is positive, like you have a plus c in there, which way does your graph actually go? Left. Good. The left and right ones are backwards of what they seem like they should be. So you're going to go left C. If you want to write the word, that's fine. So if C is negative, where's your graph going? Which to the right C. All right, then D is your up and down. Because that's outside your parentheses there. So if D is positive, where do we go? Up, yep, that one makes sense. And if D is negative, okay. Now we said for the amplitude, we always use the absolute value of A, but what does it mean if A is negative? What does it do to your graph? Yes, it just flips it. So it's going to flip over the x-axis. There is a way to flip it over the y-axis, but you guys are not going to deal with any of those, okay? Your only flip will be over the x-axis. We are starting today with just like amplitude changes, maybe a flip and a period change. We're going to get to the shifts next time. So if you look at this first one here, y equals 3 sine of x. So let's fill in our amplitude and period. What do you think? What's the amplitude? What? 3? Okay, I thought I heard somebody say 4. I don't know where that came from. So 3, yes. All right, what about the period? Is there any number right in front of x? No, so it's just going to be the same as the parent graph. The period will be 2 pi. What that means is your x-axis labels are just like we did with the parent graph. So we've got pi over 2, pi, 3 pi over 2, and 2 pi. Do your negatives. Make sure you label your y-axis. I'm going to go ahead and plot the points from the parent graph. So since it's sine, did that start at 0 or did that start at 1? 0. And you will get to a point where you are very quick with these dots. I know you're not there yet. That's okay. If you want to connect them, you can. I'm just going to leave them as dots. This is where different colors comes in handy. Okay, we haven't done it. Just right now, all we've done is parent dots. Okay, so we'll get to it. I haven't graphed it yet. Okay, so the only thing that is different is the amplitude, right? Remember, amplitude, absolute value of A. It's what's happening with the height of your graph. So what you do with this is take the y values times 3. So these that are on the x-axis, those are zeros, right? What's 0 times 3? 0. So are those points going anywhere? No. So those dots can stay. So I'll just do them in another color. The ones that are at 1, where are they going to go? 3, because 1 times 3 is 3. So they get stretched by 3. What about those dots that are at -1? Where are they going? Yep. All right, so then you just have to draw your nice curve. I'll draw the blue one in too. Again, you don't have to, but just so you can see. You guys see how it's the same graph as the parent graph? It's just been stretched out. The amplitude change, you got followed, right?
Would there be a time where the values would move like horizontally, not vertically?
So yes, we'll get into shifts next time. Like it might say shift to the right pi. So then you have to take all those original dots and move them to the right by however many tick marks pi. Okay. Ready to turn the page. You need a minute? That's okay. Alright guys, so turn the page, let's look at number 4 together. right, guys, so this time we have y equals cosine of 4x. So we can obviously all see there's a 4. Is that 4 an a, a b, a c, or a d? Like, what value are we looking at there? That's a b. Coefficient on x, that's a b value, okay? So, what is the amplitude of this graph? Like, is there anything changing? No, so what is it? 1, yes, okay. The b value, remember, changes the period. Okay, so to find the period, we do 2 pi divided by b. So for us, that's going to be 2 pi divided by 4, which ends up being pi over 2. Okay. Because the period changed, we're going to change how you label your x-axis. Guys, don't write the next part that I'm doing. If we left it these, okay? What this is telling you is that you would see 4 complete cycles of the graph by the time you got to 2 pi. So your graph would look something like, again, don't write this down. Okay, kind of messy, right? Like a whole bunch of little squiggles. What we're going to do is relabel the x-axis so that the only part of the graph we see is right here. We're going to then kind of stretch that out over here so that it's a much nicer picture of that. So the last label on my x-axis is going to match with the period for this graph. So you're going to label that one as pi over 2. Because I don't need like a crazy little squiggly worm all over your graph. We'll just look, it's going to look a lot like your parent graph. Okay, now these were my original labels. Again, you don't have to write them. Two pi turned into pi over 2. How did I do that? I divided by 4. So to relabel all of these points, you have to divide each of these by 4. Okay? So what's 3 pi over 2 divided by 4? Like times 1/4? I know we don't like fractions, but we can do it. 3 pi over 8, yes. I think you guys can do the next one. It starts as pi, and we're dividing it by 4, so what's it going to be?
Pi over 4. Pi
Pi over 4, okay, good. And then pi over 2, what is that going to be then? Pi over 8, good. So those are your new labels. We'll do the negative ones too. Did you understand how I got that? That is pi over 2. That's like you're graphing one period of it, right? Okay, so what we're going to do now, there's no plugging in these values and plotting points. You're going to graph the points in the exact same position as the parent graph points were. So with cosine, remember that's the one that kind of looks like a W. Started up here. Do the dots following the pattern. And that is the graph of y equals cosine 4x. Do you guys see why labeling the x-axis is really important now? Okay, so the period change totally changes it, all right? Do you guys want to try number 5, or should we do it together? Together? Okay. Okay, this time we've got -2 sine of 1/2 x. So I've got a negative to think about, I've got a 2 to think about, and I have a half. So what does the negative do? Flips, okay. What is the 2? Amplitude, yes, the amplitude is 2. And what is the 1/2 change? So you have to do 2 pi divided by 1/2. What do I get? 4 pi, I have to remember flipping, multiplying. So 4 pi is 3. Okay, so for labeling, what is the last tick mark to the right going to be? 4 pi. And again, think through those original labels if you need to. 2 pi turned into 4 pi. How did that happen? Yeah, multiplying by 2. Dividing by a half is the same as multiplying by 2. So what's 3 pi over 2 times 2? 3 pi. Pi times 2.
2 pi.
And then pi over 2 times 2. Pi. So your numbers, or your labels are pi, 2 pi, and 3 pi. Okay, you may not need to do this next step, but I'm going to go ahead and just plot the parent graph points for sine. So that's one that starts at 0, 0. Now what do I have to do with those points? Flip them, yes, and yes. So what if I just multiplied by -2? Would that take care of it? You can see how that would do both the flipping and, okay. So the ones that are on the x-axis, those are zeros. 0 times -2 is still 0, right? Okay, so the ones that are 1, where are they going to go? 2. The ones that are at -1, where are they going to go? I like my color choice here. Probably don't get to change colors. Okay, yes. Okay, do you understand the red dots? Okay. There's a -2 in front. Are you talking about which values? These? Okay. I am taking this -2 times the y values for each of those red points. So 0 times negative 2 is still 0. 1 times negative 2 is negative 2. Alright, questions? That's where we're stopping the notes today for the graphing, okay? Because the rest of them, do you guys see how these have shapes going on? That's next time. So we will stop there.